So we were doing the last part of maths chapter quadrilaterals, and this is midpoint theorem and its converse. And few of the solved examples were still left, and we were on the fourth solved examples. So let's continue from here. Okay, so in this question, they say that D, E, and F are the midpoints of side BC, CA, and AB respectively. Let's write given. D, E, and F are midpoints of sides AB, BC, and AC respectively. And they say that BE and DF intersect at F. BE and DF. BE and DF intersect at X. CF and DE. CF and DE intersect at Y. To prove that XY is 1/4 of BC, and there is one construction: join FE and XY. So this might seem a very complicated proof, but it is not. If you find the pattern and along with your midpoint theorem, if you look out for certain properties of quadrilaterals, especially parallelograms, this is a very easy proof. Okay, so we know that F and E are midpoints of AB and AC. Therefore, we can say that FE is parallel to BC and FE will be half of BC by midpoint theorem. FE will be parallel to BC and FE will be half of BC by midpoint theorem. Great. After this, you can say that therefore FE is equal to BD and FE is equal to DC. Why? Since BD is equal to DC is equal to half of BC. Since D is the midpoint. So BD and DC both are equal and they both are equal to half of BC. And that's why since FE is also half of BC, FE is equal to BD and FE is equal to DC. Okay. Great. And similarly, hey, there is no requirement for similarly. Also, there is no requirement for also. I'm sorry for that. Okay, so what we can say that in quadrilateral, FEDB. Can you see quadrilateral FEDB? In quadrilateral FEDB, FE is equal to BD and FE is parallel to BD. Therefore, FEDB is a parallelogram. FEDB is a parallelogram. Okay. Similarly, FECD is also a parallelogram. Why is FECD a parallelogram? Because FE is equal to DC and FE is parallel to DC. Okay, so if one pair of opposite sides of a quadrilateral are equal and parallel, then it's a parallelogram. So we proved that FEDB and FECD are parallelograms. Great. Therefore, we can say that FD and BE bisect each other at X. FD and BE bisect each other at X. Why do they bisect each other at X? Because they are the diagonals of a parallelogram. Similarly, FC and DE, FC and DE also bisect each other. Also, FC and DE bisect each other at Y, since they are diagonals of a parallelogram. Okay, so if FD and BE bisect each other at X, we can say that X is midpoint of FD, right? So therefore we can say that therefore X is midpoint of FD, right? FD, right? Let me check. FD, yes. And Y is midpoint of DE. And Y is midpoint of DE. Y is midpoint of D. Okay. So in the small triangle DEF, we are considering the small triangle DEF. X and Y are midpoints of DF and DE. Okay. In triangle DEF, since X and Y are midpoints of DE and DF, XY will be parallel to XY will be parallel to FE and XY will be half of FE. XY will be parallel to FE and XY will be half of FE by midpoint theorem. Right? So XY is parallel to FE and XY is half of FE by midpoint theorem. Also, in triangle ABC, FE is parallel to BC and FE is half of BC. Why? Because F and E are midpoints of AB and AC. So by midpoint theorem, we can say that FE is half of BC. Now see, XY is half of FE, equation 1 or statement 1. FE is half of BC, statement 2. So from 1 and 2, from statement 1 and 2, we can say that xy is equal to half of, see, in the place of FE I'm going to write half of BC, that is 1/4 of BC. xy is 1/4 of BC. That's what we needed to prove. So using parallelograms, we can prove that f x and y are midpoints of FD and DE respectively, which helps us prove that xy is half of FE by midpoint theorem in triangle DEF, and in triangle ABC we can easily prove that FE is half of BC by midpoint theorem. So using these two statements we can easily prove this question. Let's move to the next question. In figure, ABCD and EFGC are rectangles, okay, where F is midpoint of AC. F is midpoint of AC, okay. Prove that DE is equal to EC and EG is half of AC. Okay. Let's write what is given. ABCD and EFGC are rectangles. F is midpoint of AC. To prove, number 1, DE is equal to EC. Number 2, EG is half of AC. Construction, we have to do a construction as shown in the figure. Join BD and EG. Join BD and EG. Proof. Now see, we know that F is midpoint of AC. Okay. So which triangle should we consider in order to apply midpoint theorem? See, F is midpoint of AC. Okay. So in triangle ABC, now we have to consider triangle ABC. In triangle ABC, F is midpoint of AC. Do you agree with me? F is midpoint of AC. Why? Because it's given. Also, FG is parallel to AB. Why FG? Why is FG parallel to AB? FG is parallel to AB since angle FGC is equal to angle ABC, both 90 degree, right? So since they are both 90 degree, they become corresponding angles, and since corresponding angles are equal, the lines FG and AB will be parallel. AF and FC are already equal to each other, so F is the midpoint. So therefore we can say that G is midpoint of BC. G is midpoint of BC by converse of midpoint theorem. So we proved that G is midpoint of BC by converse of midpoint theorem. And we proved that AF is equal to FC, which was given. We proved that FG is parallel to AB. Okay, and we proved G is midpoint of BC by converse of midpoint theorem. Great. Now what? Now we have to prove that DE is equal to EC. That is, E is midpoint of DC. This can be proved, but which triangle you will take, that is the main thing. See, we know that this is a rectangle, EFGC is a rectangle, so this will be 90 degree. Also, this will be 90 degree, right? And we know that EF is parallel to AD. EF is parallel to AD. Okay, so we know that F is midpoint of AC, EF is parallel to AD, so we can apply converse of midpoint theorem and prove that E is midpoint of DC. Let's do that. So in triangle ADC, I will require all of you to use your visualization and just focus on what I'm trying to tell you. In triangle ADC, F is midpoint of AC, which is given. F is midpoint of AC. FE is parallel to AD, since angle FEC is equal to angle ADC is equal to 90 degree, and they are corresponding angles, so the lines will be parallel. Okay, therefore we can say that E is midpoint of DC by converse of midpoint theorem. Okay, so we have proved that DE is equal to EC. E is midpoint of EC. E is midpoint of DC. Okay. Okay, now since we have proved that E is midpoint of DC, we already know that we have already proved that G is midpoint of BC. Now I just want you to visualize one triangle with the help of which we are going to prove the second part. Okay, the triangle which I want you to visualize is this one. Can you visualize this triangle? This is triangle DBC. So in triangle DBC, E and G are midpoints of DC and BC respectively. Let's write it. In triangle DBC. In triangle DBC, E and G are midpoints of E and G are midpoints of sides DB and DC respectively. E and G are midpoints of sides DC and CB respectively. DC and CB. I'm sorry for that. DC and CB respectively. E and G are midpoints of DC and CB respectively. Right? So EG is parallel to BD and EG is half of BD. Therefore, EG will be parallel to BD and EG will be equal to half of BD by midpoint theorem. EG is parallel to BD and EG is half of BD by midpoint theorem. Okay, but BD is equal to AC. Diagonals of rectangle are equal. Diagonals of rectangle are equal. Therefore, we can say that EG is half of AC. That's the last thing we have to prove. EG is half of AC. Right? So we had to apply converse of midpoint theorem twice, and then we had to apply midpoint theorem to prove EG is half of BD, and then since BD was equal to AC, diagonals of rectangle are equal, we proved that EG is half of AC. Nice question. Let's go to the next question. So these are the typical questions of midpoint theorem. You will always find such questions in midpoint theorem, specifically in this chapter quadrilaterals, because you will see that there is application of properties of parallelograms also, and also midpoint theorem, like this one, the question in front of us. ABCD is a parallelogram. Let me write given. ABCD is a parallelogram in which E is midpoint of DC. E is midpoint of DC. F is a point on AC such that CF is 1/4 of AC. Okay. So CF is equal to 1/4 of AC. Great. EF produced meets BC at H. Prove that H is midpoint of BC. To prove H is midpoint of BC. Okay, so there is one construction which is required. Join BD. Okay, now we can prove it easily. Now see, we can say that AO is equal to OC is equal to half of AC. That is, O is midpoint of AC. Why? Since diagonals of parallelogram bisect each other. Diagonals of parallelogram bisect each other. AO is equal to OC is equal to half of AC. Okay. Also, CF is equal to 1/4 of AC. CF is equal to 1/4 of AC. So, we can find a relationship between CF and OC. So, we can say that, therefore, CF is equal to 1/4 of, in the place of AC, I am going to write 2 times OC. So, this will become, therefore, CF is half of OC. See, CF was 1/4 of OC. Now, sorry, CF was 1/4 of AC and CF was half of OC. And OC was, sorry, OC was also half of AC, correct? Right? So, CF becomes half of AC. So, F becomes the midpoint. F becomes the midpoint of OC. Therefore, F is midpoint of OC. F is midpoint of OC. So therefore, we'll consider triangle DOC. In triangle DOC, E and F are midpoints of CD and CO respectively. In triangle DOC, E and F are midpoints of sides DC. Let me just check. E is midpoint of DC and OC. F is midpoint of OC respectively. Right? In triangle DOC, E and F are midpoints of DC and OC respectively. Therefore, we can say that EF is parallel to OD, I think. Yes, EF is parallel to OD and EF is equal to half of OD by midpoint theorem. EF is parallel to OD and EF is half of OD by midpoint theorem. Great. So we have to prove that H is midpoint of BC, which can be proved very easily. Let me show you. Now, since EF is parallel to OD, can we say that EH is parallel to BD? Therefore, we can say that EH is parallel to BD since EF is parallel to OD. If we extend EF and if we extend OD, we get EH and BD, right? So we get EH is parallel to BD. Great. And E is midpoint of DC. E is midpoint of DC. So have you figured out which triangle we are considering right now? See, we have proved that BD is parallel to EH and E is midpoint of DC, right? So we are considering triangle this BDC. So in triangle BDC, H will be the midpoint of BC by converse of midpoint theorem. Therefore, by converse of midpoint theorem, H is midpoint of BC. Did you understand which triangle we took? We took triangle DBC. So we have to mention that in triangle DBC, EH is parallel to BD and E is midpoint of DC. So by converse of midpoint theorem, H is midpoint of BC. Hence, it is proved that H is midpoint of BC. So this was a very typical question which is generally asked in exams in the topic of midpoint theorem. Okay, so we are just on the last question of midpoint theorem. Okay. Does not have a diagram. Let's draw it. E and F are the midpoints of non-parallel sides AD and BC respectively of a trapezium ABCD. Okay. Prove that EF is parallel to AB. Great. Given. In trapezium ABCD, AB is parallel to CD. AB is parallel to CD. E and F are midpoints of AB and BC respectively. E and F are midpoints of AB and BC respectively. To prove EF is parallel to AB, and we have to do a construction that EF, draw EF, join EF and join AC. So I have not done that construction yet. Let's do that. So join EF and AC, and let's name this point as P, where AC intersects EF. Great. Okay, let's see how to do this. Okay, so here we are going to use equal intercepts theorem, if you remember that. So by equal intercepts theorem, a transversal AD is cutting three lines AB, EF and DC, out of which AB and DC are parallel. EF we do not know about, but it is making an equal intercept. It is making two equal intercepts, that is AE and DE. So any other transversal cutting these three lines will also make equal intercepts, right? So we can say that by equal intercept theorem, AP is equal to PC. Okay, so therefore we have proved that P is midpoint of AC. So in triangle ADC, since E and P are midpoints, E and P are midpoints of AD and AC respectively, E and P are midpoints of AD AD and AC respectively. Therefore, we can say that EP is parallel to DC and EP is equal to half of DC by midpoint theorem. And therefore, we can say that EP is also parallel to AB. Why? Since AB is parallel to DC. Okay. And therefore, we can say that EF is parallel to AB. Why EF is parallel to AB? So if EP is parallel to AB, then if you extend EP ahead, AB will also become parallel to EF. EF will also become parallel to AB. Yeah, so we can use equal intercept theorem and we can prove this. Also, the use of midpoint theorem is there. Yeah, so there is one last exercise which is 8C after this part, and there are 12 questions in 8C. So I'm going to give you this exercise as homework. After watching this video, please solve this exercise so your concepts are clear. Okay, so I'll see you in the next video. Bye-bye.